All right, so today we're going to be talking about Chapter 9, Lesson 3. This is all about probability of compound events. Now, the first thing that we're going to talk about is how to find something called a sample space. So, first of all, a sample space is all of the possible outcomes. A couple of ways that we can do it. We can either come up with a list, which depending on how many different options there are, the list is not a good idea. We can also do a table. We could also do something called a tree diagram. Now, all three of these work well with small numbers. For example, you would not want to use a list, a table, or a tree diagram to find out all the different combinations of phone numbers you can have with even just the 3 at the front and 4 at the back. That would be a very large list, table, or tree diagram. So, example 1. It says Melinda has 4 pictures that she wants to place in a column in her scrapbook. Use a list to represent the sample space for the different ways she can place the pictures. First thing I'm going to do is I'm going to draw a picture. And we have 4 different spaces where each picture could go. Now, let's just assume that we're going to put the first picture first. And then we could put the second one, and the third one, and the fourth one. We could also switch the back 2, or switch 2 and 4. We could also switch 2 and 3. Or we could switch now the 2 and 4. And we could switch the 2 and 3 here as well. So we could have all of those different combinations if we simply do the first picture first. Now let's do the second picture first. So 2, 1, 3, 4. We could also have 2, 1, 4, 3. We could also have 2, 3, 1, 4. 2, 3, 4, 1. Could also have 2, 4, 1, 3, or 2, 4, 3, 1. Right now we are at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different combinations that we could have so far. Now, if we do the third picture first, we could do any of these as well. And then, of course, if we put the fourth picture first, 1, 2, 3. So 4, 1, 3, 2. 4, 2, 1, 3. 4, 2, 3, 1. 4, 3, 1, 2. And then 4, 3, 2, 1. So a list, even though it's going to get you all of the different kinds of things, the different outcomes, it's still a very long process. And we only used 4 pictures. So there are 24 different possibilities for our sample size, or for our sample space. So this, right here, all the way down and across, this here is the sample space. Example 2. An Italian ice shop sells lime, cherry, blackberry, and watermelon Italian ice. It is served plain, mixed with ice cream, or as a drink. Use a table or a tree diagram to find the sample space for the different orders that can be made. Now, if we make a table, we have, looks like flavor, and how it's served. We have 4 different kinds of flavors. We have lime, cherry, blueberry, watermelon. So what I'm going to do is I'm going to do lime, cherry, blueberry, watermelon, and kind of separate those 4 flavors. Now, it can be served either plain, so P, mixed with ice cream, so M, or as a drink, D. So we could have lime plain, lime mixed, lime drink. Same thing here, we could have cherry, plain, mixed, or drink. Blueberry, plain, mixed, or drink. Watermelon, plain, mixed, or drink. So that's our sample size there. If we used a tree diagram, I would still want to do the same kind of process, flavor and how it's served. It's going to look very similar. The only difference is, instead of it looking like a table, it's going to look kind of like a tree. So we'd want to make a table or a tree diagram that looks like that. Either way, both are going to be a great way to show how to make a sample space. Now that we have the sample space, we can actually try to find the probability. So if we find probability of a compound event, we have to first identify what a compound event is. So a compound event is 2 or more events happening together. For example, example 1. There are 4 pictures that could be chosen here. Once one of them is chosen, we only have 3 for this one. Once one of them is chosen, we only have 2 for this one. And then it makes our job really easy to choose our last one. That's a compound event because we have 1/4 here, and then we have 1/3 and 1/2 and 1. Here, this is a compound event. You can choose a flavor and then how it's served. So, example 3, it says this cool cafeteria gives students 2 choices of snacks. You can either pick carrot sticks or pretzels. They also offer a beverage choice of apple juice, milk, or water. Find the sample space for all possible outcomes with 1 snack and 1 beverage. And then what's the probability of ordering pretzels and apple juice? So, 2 snacks, carrots, pretzels. 3 choices of juice. We have apple juice, we have milk, and we have water. So we could have carrots and apple juice, carrots and milk, carrots and water. Same thing with pretzels. So I could choose pretzels and apple juice, pretzels and milk, pretzels and water. This right here is the sample space. Next, it says, what's the probability of ordering pretzels and apple juice? So, we want to do the probability of pretzels and apple juice. And that's going to be, again, successes out of total outcomes. There are 6 items in our sample space, which means that we're going to have 6 possible outcomes. Looking through my sample space, there's only one that is pretzels and apple juice. So the probability would be 1 out of 6. If we were to change that to a decimal, it'd be about 0.17. As a fraction, 17%. All right, that is the end of lesson 3. If you have any questions, please let me know.